It's a pleasure to me to welcome you in Etnetera core offices. My name is Petr Studený, and I've been working with Etnetera since 2012. So it will be 20, I'm sorry. It will be three years already. And I'm a DevOps engineer, and with a background of Linux administration. And when I come to Etnetera, our first project was to build the first project running Kubernetes. And so we had to decide what will be used to deploy our application to Kubernetes. And after some struggles, we decided for Kustomize. So I will be talking about it today. So first, we will just scratch the surface to know how the Kubernetes works and how do you communicate with it. To communicate with Kubernetes, you need Kubernetes API, and that's everything that you want to do with the cluster must be done through the Kubernetes API. And there is the kubectl tool, which is like the foundation tool that is used. But also, of course, you can use whatever tool you want to communicate with the REST API. And the REST API specification of Kubernetes includes put and patch methods, and also dry run, which is cool that you can run your requests against the Kubernetes, and you can just check what would happen if you run it. In the REST specification, the put method is used to create the resource if it is not existent, and to update it if it already exists in the Kubernetes. And that means that it's a declarative, and it should be idempotent if you run the put method like several times, and it should just create the resource there. And the patch method, it works with a partial payload that you don't have to create the whole resource again, and you just send a part of the data, and the existing resource in the Kubernetes should update. So if you need to run something in Kubernetes, you have to write your manifests according to the specification. And for that, to apply it to the cluster, you use the kubectl apply or other commands of kubectl. So the apply, it is counterpart of the put method. So it will create the resource if it is not there, and if it will update it if it is already existent. There are some fields of the manifest that can't be updated when it is already there. So if you need to make a change, you can always use the replace command, which will delete and then recreate the resource in the Kubernetes. There's also a patch command, which again uses the patch method to apply like partial update using a strategic merge, JSON merge, or JSON patch. So it is built inside the Kubernetes API. The strategic merge requires a merge strategy, which must be defined in the API reference of Kubernetes itself. You totally don't want to keep all your manifests on, I don't know, on disks and to deploy them like directly from the manifests, which are some JSON or YAML files. And if you want to build like several environments of your application, for example, a dev, stage, or production environment, you need to somehow parameterize your manifests to deploy them. So you want to deploy your applications to the cluster, and you would like to change it a little bit for each environment there. for that, you need some Kubernetes configuration management system. And the most known, I suppose, is Helm. So I would like to ask you if anybody is using actively Helm. Okay, like a third, maybe more, who use Kustomize. Okay. And is there anybody who uses JSONet? Okay, also a few people. And there are another management systems like KPT. You can create your manifest using Ansible, Terraform. There is the whole like ecosystem, or how to say it, for the infrastructure as a code called Plume, and there are a bunch of other management systems. But Kustomize, it's a native part of kubectl, but you can download it also as a standalone binary. As I already mentioned, a lot of API capabilities are used directly in Kustomize. So in Kustomize, you use approach where you like rebase or patch, like in software packaging. So for example, in my experience, when we developed some embedded systems, we took a vanilla Linux kernel, and then we wrote some changes. We created our like diffs, and then we could apply the patches on the Linux, and then build it with some changes that we needed. So the Kustomize works similarly. And that enables you to use some third-party manifests or from other team, let's say, and to patch it somehow, and then you can rebase it. So if the resource, the base changes, you can still use it. The Kustomize embraces manifests, so it's built around the objects that are defined within the Kubernetes, and it knows it. So it's like different than from the plain diff, because in plain diff you have to create some context, which is usually some lines before the change and some lines after the change, and some like the starting line number and the end of the block. But here we are using the JSON or YAML objects, which are like objects, so the Kustomize knows that it is a valid Kubernetes resource, and it can use it. The Kustomize is declarative, which is great for GitOps approach, but there are also some commands of Kustomize that allow you to imperatively edit some resources there. Like the beautiful thing about Kustomize is that it's template free, and so you don't find double braces in Kustomize. And for example, with Helm, when you need to create a totally like modifiable resource, you will end up with some kind of skeleton full of empty fields that are to be filled using the Helm values. In Kustomize, you can write your the base, and then you can enrich it again and again on later layers. With Kustomize, when you create your base resource, it should be a valid Kubernetes manifest, which is nice because you can test like each layer if it is valid, and you don't have some kind of intermediate state which is like not readable at all. And the disadvantage of Kustomize is that config map key, for example, is the smallest item that you can change. You can't create like the configuration tree of the config map using Kustomize. It like can't modify such fields. Okay, so that was for the scratch. Now, a little dive. So you have to create your customization YAML file For that, you can use the Kustomize binary with the init command, and you can detect your manifest if they are already present in your current directory or another, and you can create the customization file so it will include all the resources that you need. So the customization YAML looks like this kind. There is an API version and kind, and there are some expressions in the YAML that allows you to create or modify the manifests. With namespace, you can change the namespace of all the resources that are to be deployed. With images, you can change the images. With replicas, you can set the replicas of your deployment or stateful sets. And the resources are to include all the manifests that you need. There are also components. And with patches, yes, you can patch the resources that you included. There is a config pump generator or secret generator, etc. So for the resources, it looks like this. There is a bunch of options how to include your resources in there. You can use a directory with a customization YAML, such in base. You can use direct manifests. You can also reference a remote, in this case, repository. It could be, I think, whatever HTTP server. And you can use a Git protocol, I mean the SSH or HTTPS. And nice about the Git reference is that you can reference not only master, but you can reference any other Git reference like tag or even commit. Also, you can include the manifest that or the directory that is not in the root of the Git repository, but it is on some subpath. So you can just, with the // you can define the subpath and you can build your manifests on it. There are also components which are like resources, but it can be like included from multiple overlays. And okay, I will tell you more. And the component can apply patches on resources that were included in other resources. So it's good for writing dry manifests, let's say. Okay. So in Kustomize, there are two fundamental concepts, or maybe there are more, but the fundamental are generators and transformers. And they are usually not used directly, but using some expressions as I showed you before, like a config pump generator and secret generator. If it's a generator, it means that you create something from scratch, something non-existent, and the transformer just transforms some already existing item or whatever. There is a Helm chart inflator, which is a special kind of generator, and you can write your own generators or transformers if you would like to enrich the Kustomize. The expressions, images, namespace, replicas, patches, etc., are implementations of transformer. The generator and transformer usually are defined within the customization YAML file with their expressions, but it could be directly included using a special expression for generators or transformers. Okay, the most important thing about the Kustomize is patches, because you patch your bases, maybe. So you can target your resources that are to be patched using mostly kind and name, or you can use label selector if you use it in your base resources. It uses ensures regex, which is great because you can patch several resources at once. For example, using a group in your regular expression. The patch itself can be defined inline in the customization YAML file, which is nice because you have like everything in one place, but it can be like it can grow very big, so you can also use a file for your patch. So the patch can be in form of JSON patch. It's great for brief syntax because you don't have to provide a big context, but you use a JSON pointer, which is defined in this RFC. You can find it if you want. And the interesting thing is that it uses a slash as the delimiter for the path in your resource. So if you would like to use a literal slash, you have to encode it as a tilde1. And the tilde is now a special character. So if you would like to write a tilde, you need to encode it as tilde0. The disadvantage of JSON pointer is that you can't address the list item by its value. So you have to use indexes to the index, which is not very great if your base contains some list and the order changes, you don't know, and the patch can break. So with the JSON pointer, you find what you would like to change, and with the JSON patch, you create or replace or modify how it should look now. There are commands like add, replace, and remove, which can do what it says. And if you would like to, for example, add a new item to the end of lists, you have, for example, some environments in your deployment, and you would like to append, you use dash. Or even if you would like to remove from the end of the list, you can remove. I have to warn you, if you remove your items, keep in mind that the indexes change. So, for example, if you need to remove two items in the list, you like remove the same index twice. Okay, here is an example of JSON patch. You can see there is a regular expression that matches my backend and frontend deployment, and I would like to add disk, some drive for persistent data. Okay, in deployment it's weird, but why not? And so you use your JSON pointer with the path, and I would like to add a new volume called import to the volumes, and then I have to mount it, so I can just add to the container of index 0. At the end of its volume mounts, a new mount called import. And yeah, there is another like example of the tilde. I would like to enable forwarding of the approximing REST controller. So in here, I need to use the tilde1 to write a literal slash which is in the annotation. Okay, that was a JSON patch, and there is another approach which is called strategic merge, which is verbose because you have to provide the context, and the context must be as big as needed, and you have to declare something there, and it is using the how to say it. It's in-house like application implementation for Kubernetes. But if the resource is not known to the Kubernetes, it is treated as a JSON merge, which is described in the RFC. About the strategic merge, there is a nice thing that you can delete the whole YAML objects, because in the JSON merge, JSON patch, you can't. But with the special key patch delete, you can delete the whole thing there. So in this example, I don't need the service for Selim agent. So I just use this special key, and the whole resource vanish. So, for example, if I include it from some base contains the service and I don't need it, I can delete it using the strategic merge. If you would like to use the strategic merge on some custom resource definition, you have to declare the strategy in the API reference. Okay, so yeah, for the strategic merge, the metadata name is required. So, and if you would like to patch like several resources at once, you have to provide some metadata name. So you can write anything there. It is required, but it is not used. Okay. There is another thing how to modify your resources. It's called replacement, and in there you can address list by its content, which is great. Like in JQ or JMS path, if you know. It's very nice. You can declare multiple targets in a single resource, which is useful. It offers also partial string replacement. So if you declare your delimiter, you can replace just part of, well, let's say, path. The disadvantage is that the source can be defined like literally. But you need to use some resource to take the value from. So for example, you have to use some annotations, or you can create a config map with your values that you are using as a source for your replacements. Yeah, here's an example of the replacement where I target the subject's list of role binding. And I use its content with name, which is at the devel, and I change the namespace there. Yeah, okay, let's speak something about extras. There is the kubectl diff, which you can use with the manifest itself, with -f, but it's also possible to use it with -k, where you provide the directory with the customization file. But when you create your resource in the Kubernetes, it adds some additional fields in the resource, so it can be noisy. So I created this alias, which creates for me the diff that is more readable. You can see that if you would like to use Helm inside Kustomize, you have to enable it like with this argument. There is Kustomize localize, which is a quite recent new command. And as I said, that you can use resources that are remote. You maybe need to localize it to make it like local. So with Kustomize localize, you can resolve the dependencies. You could always use the Kustomize build to get the final manifests, but with Kustomize localize, you will keep your structure of layers for some maybe other modifications. Okay, so there is the Helm chart inflator, and I will speak about it. And the thing is that the Helm chart inflator is not like supported very much in the Kustomize community, and they suggest to use KRM functions. I don't know if you heard about it. It's like it should be built directly in the Kubernetes, and it's a way how to enhance the tooling. It works like a little containers where you put some standard input with your manifest and some specification what should happen inside the functions, and on standard output it will build some final manifests that are to be deployed. Okay, so the Helm chart inflator, as I said at the beginning, you can use your generator with the shortcut in your customization YAML, but this approach is buggy in Kustomize. There is a GitHub issue opened several years, but with the generators approach, where you defined your file with the generator in your customization YAML, and then you can create a manifest of kind Helm chart inflation generator. That way it works. You have to enable it using this enable Helm argument. Otherwise, the Kustomize will just pop some error message that it is not enabled. Yeah. There is another feature or issue. I don't know. There is some discussion under this link that if you create if you use the Helm chart in Kustomize and you build your manifests there, it will create a directory for the charts in your current directory. And if you, for example, change the version of your Helm chart, it is not pulled if already present. So you have to delete the directory yourself. Okay, and the great thing about the Helm chart inflator is that you can use the Helm, generate the manifests, and you say, okay, the Helm is not so versatile as I wish. I would like to, I don't know, add some volume there, add some limits there, or maybe, I don't know, some affinity, whatever. So I can use it as a base layer for some other Kustomize layers, and I can modify it. Yeah, okay. So, and the last slide is like from the wild. As I said, that you can use remote resources, and the remote resources can use a Git reference. You can end up with something like this. Because we are a project company, we create a project with like different applications, but for deployment it's similar. So we use similar base layers for different projects, and in each project have several environments, and each environment use like different bases. Yeah, maybe I will open it using this. So, for example, in project 1, I have some production environment in which I defined that the image should be this, and I need, for example, 3 replicas of the application, and it uses application 1 and application 3, and the development environment of this project uses also the application 1, but the application 3 is on different tech. So there has been some change in the customization of application 3, and you are not ready to deploy it on production yet. So, but you can deploy it on dev. And for example, in here, I have some common customization for some infrastructure application. And here you can see that the production uses some old tags, but the dev and test is on different tags. And at the end, it can look quite difficult to read. Okay, so that's all from me. Thank you for your attention, and you can have some questions.
Thank you. Thank you for presentation. I have only one question, and I think I'm not one eager to know, why did you choose Kustomize over Helm?
Because I don't like double braces. I know. It's because that with Kustomize you can create small iterations. That, you can build your like the manifests, like plain manifests, and when you are like quite okay with it in your like proof of concept, you can use it, and then or you can enhance it. And as I said, we are a project company, so we build a lot of different applications, which differs a lot. And with Helm, if I would like to make some change, I have to go to the Helm, to the template, to change it there, and then I have to apply it for all my projects. But with Kustomize, I can just apply a tiny patch over the base that is common for all the projects that I use.